Good morning to all of you. So today I am going to discuss the second law of thermodynamics. So this second law of thermodynamics is in third unit. But before that one, what are the limitations of a first law? Then what are the statements connected to the second law of thermodynamics? What are the terminologies? That is heat engine, heat pump, refrigerator, air conditioner, which are connected to that one. Next, after then, we need to study the corollaries of a second law of thermodynamics, perpetual motion machine of the second kind. Then after then, the Carnot's theorem and Carnot cycle. Finally, the Clausius inequality. So these are the topics which are connected to this particular side. Now, what are the limitations of the first law? That is, according to the first law, which it is obtained that heat and work are mutually convertible. But according to the second law, it is not at all possible because heat is a low grade energy and work is nothing but the high grade energy. So mutual convertible process is not possible. So that particular information is not given by the first law. So the second law indicates the limit of converting the heat into work and introduces the principle of increase of entropy. So the another limitation is that the direction of the process, whether the process is feasible or not, so that particular information is also not given by the first law of a thermodynamics. So the second law of thermodynamics is going to indicate the process feasibility and also the direction of the process. So all that particular information you can get it from the second law of a thermodynamics. That means how much possibility of heat can be converted into the useful work. So that particular information you can get it from the second law. But according to the first law, all the heat can be converted to the work and all the work can be converted to the heat. But practically it is not possible. So that particular limitations are connected with the first law of a thermodynamics. So before going to that one, there are certain things which you need to study. Then why we have to study the second law of a thermodynamics? Everyone has to make the questions here. Because according to the Joule's experiment, demonstrated that the energy is conserved. That means all the work can be converted to the heat and all the heat can be converted to the work. But how much heat can be possible to convert that into the useful work? So that particular to get that particular information, then you need to study the second law of thermodynamics. So the loss of energy due to the irreversibilities can be minimized by minimizing or eliminating the causes of irreversibility. So in this case, the certain basic definitions you need to learn. That is thermal energy reservoir. It is defined as an infinite heat capacity of a body capable of absorbing or rejecting an unlimited quantity of heat without suffering any appreciable changes in thermodynamic coordinates. So that means it is a infinite heat capacity of the reservoir, which its property will not change when you add or remove certain amount of a uh, heat to the system. So that is nothing but the thermal energy reservoir. Whereas a mechanical energy reservoir is it is a large body enclosed by a adiabatic impermeable wall capable of storing work as potential energy or kinetic energy. So all processes of interest within a mechanical energy reservoir are essentially quasi-static, and a mechanical energy reservoir receives and delivers mechanical energy quasi-statically. So the cyclic heat engine, it is a device which converts the available heat into work by rejecting certain amount of heat. So this is the heat engine diagram which produces the work output by exchanging heat with two reservoirs, by exchanging heat with two reservoirs. So on this particular connection, for the efficiency, where you need to connect it to the uh, efficiency. Next one is the refrigerator. So for the refrigerator, air conditioners and heat pumps, you need to mention the coefficient of a performance. So it is defined as the ratio of desirable effect to the work spent onto the system. So if you want to transfer the heat from low temperature reservoir to the high temperature reservoir, some work must be spent onto the systems. So this is the air conditioner diagram, and this is the heat pump diagram. For these two cases, you need to mention the coefficient of a performance. So next one is the second law of a thermodynamics. These are the two statements which are connected. That is the Clausius statement and Kelvin Planck statement. Clausius statement states that it is impossible for a self-acting machine working in a cyclic process unaided by an external agency to convey the heat from a body at lower temperature to a body at high temperature. So in other words, heat itself cannot flow from cold body to the hotter body. Whereas the Kelvin Planck statement states that impossible to construct an engine which while operating in a cycle produces no other effect except to extract heat from a single reservoir and do equivalent amount of a work. So that means if you want to get the work output, the cyclic heat engine has to exchange heat between the two reservoirs. So this Kelvin Planck and Clausius statements, though the statements are different, but you have to prove that these two statements are equivalent to each other. So this is also one of the diagrammatic sketches you need to draw, and finally you have to prove the a violation of a one statement leads to the violation of the other statement. So if you can prove that the violation of a Kelvin Planck statement, it is going to lead to the violation of the Clausius statement. So this is how you are going to prove the Kelvin Planck statement and Clausius statements are parallel statements connected to the second law of thermodynamics. Now there is one important parameter, that is energy efficiency rating. Especially this is used for the refrigerators and air conditioners. Mostly this particular technical term is using in United States, that is in terms of the British thermal unit. So one British thermal unit is equal to it is thermal equal to 3.412. So that is 1 kilowatt hour is equal to 3412 British thermal unit, or 1 watt hour is equal to 3.412 British thermal unit. BTU is nothing but British thermal unit. So the energy efficiency rating is equal to 3.4 times the coefficient of a performance of a refrigerator, or it may be the heat pump. So most air conditioners have the energy efficiency rating in between 8 and 12, where the COP is in between 2.3 to 3.5. So this is how the energy efficiency, so it is mentioned in terms of the performance of a refrigerator or air conditioner. So the energy efficiency rating, or COP, of a refrigerator decreases with decreasing refrigeration temperature. So it is not economical to refrigerate to a lower temperature than needed. So these are the some statistical values which are mentioned, the energy efficiency rating of different uh, cold systems, the different cold systems. Then after then, you need to study the corollaries of a second law of thermodynamics. So the corollaries of a second law of thermodynamics, there are five statements are there. In addition that none of the engine is more efficient than a reversible heat engine. And the second corollary is nothing but all the reversible engines will have the same efficiency when it is operating between the constant temperature source and constant temperature sink. Then after then, there is a Clausius theorem is there, that Clausius theorem is going to indicate whether the cycle is reversible or irreversible or impossible cycle after making the calculation with that particular system. Then in the second law of thermodynamics, the Carnot's theorem also you have to study. So the Carnot's theorem and the Carnot cycle. So the Carnot cycle is consisting of Carnot cycle is consisting of four processes, that is two reversible two reversible isothermal process and two reversible adiabatic process. Two reversible adiabatic process. So these are the four processes which are connected to that one. And the Carnot's theorem states that none of the engine is more efficient than a reversible heat engine. So these are the studies which you are going to uh, study in second law of thermodynamics. This is all about the second law of thermodynamics. Thank you, one and all.